In this video, we will practice solving polynomial inequalities. This is AP Precalculus topic 1.5. If you appreciate the content, please hit the like button. The first step of solving a polynomial inequality is to make a list of zeros. In factored form, this is super easy. So f of x is going to equal 0 at x equals 0 from this first factor, x equals -1 from the second factor, and x equals +2 from the third factor. By the way, we are referring to this part of the polynomial as f of x. Next, you want to make a sign chart. We need a row for every factor. So since I have 3 factors, I made 3 rows. Don't forget to label the sign chart in the upper left-hand corner. Call it f of x. So in the first row, we have 3x. In the second row, we have x plus 1. And in the third row, we have x minus 2. I've made a vertical line to represent each one of these zeros. We need to label these in order from least to greatest. This is really a number line across the top. So be sure to put the -1 first, and then the 0, and then the 2. Next, we decide whether these factors are positive or negative in each interval. Let's start with 3x. 3x gave us the 0 of 0. So this is the only place where the sign might change. 3x is going to be negative to the left of 0 and positive to the right of 0. X plus 1 gave us a 0 of -1. This factor will be negative for values of x less than -1 and positive for values of x that are greater than -1. X minus 2 gave us the 0 of 2. This factor will be negative for x values less than 2 and positive for x values that are greater than 2. But what about the overall sign of f of x? We can just count the negatives. If you see an odd number of negatives, then f of x will be negative in that interval. If you see an even number of negatives, f of x will be positive in that interval. In the third interval, we see only one negative, so f of x is negative, and everything's positive in the last interval, so f of x will be positive. Next, we need to decide, are we looking for where f of x is negative or positive? Well, the inequality says that f of x is less than 0. That means we are interested in where f of x is negative. So the solutions will be in these intervals. So for the first interval, it goes from -∞ to -1, but we have to be careful and consider whether we will use brackets or parentheses. Infinity always gets a parenthesis. However, the endpoint, the number, sometimes will be a parenthesis and sometimes will be a bracket. Sometimes it'll be like this, sometimes it'll be like this. And that depends on whether we have a less than or equal to. If we only want the values that are less than 0, then we do not want to include values like -1 where f of x is equal to 0. And we show that an endpoint is not included with a parenthesis. So if it's not or equal to, use a parenthesis on the endpoint. We have another interval, so we're going to say union, and this interval goes from 0 to 2. All right, with parentheses because not equal to 0, only less than. So that's the answer to number 1. Pause the video and try to do problem number 2 by yourself. All right, I'm going to assume you did that. So the zeros. Where does f of x equal 0? That -2 doesn't give us anything. No zeros there. So our first 0 is at x equals -3. And then we'll have another one at x equals +6. So we only have 2 zeros. Time to make the sign chart. Label it f of x, and we have a row for every factor. So I'm going to put a -2 here, an x plus 3 here, and x minus 6 here. All right, I have a vertical line for each of these zeros. Put them in order from least to greatest, so that's negative 3 here and 6 here. In the first row, negative 2 is a constant, so that's always going to be negative, obviously, so we'll have negative, negative, negative in that row. The factor of x plus 3 gave us the negative 3, 0. This factor will be negative to the left and positive to the right of negative 3. X minus 6 gave us the 0 of 6. This factor will be negative to the left and positive to the right. In the first interval, f of x will be negative because I see an odd number of negatives. It will be positive in the second interval because I see an even number of negatives, and negative in the last interval because there's only one negative, an odd number of negatives. Do I want the positive intervals or the next intervals for my solution? Well, f of x is to be greater than or equal to 0. So we need to focus on the intervals where f of x is positive, thus greater than 0. So that's the interval from negative 3 to 6. So let's write that down. Whoops. Okay, my phone distracted me. So from negative 3 to 6, but be careful with the endpoints. They will be brackets because this says greater than or equal to 0. So we want to include the endpoints. So this is the solution to number 2. I'm not going to say it every time, but whenever I switch to a new problem, I encourage you to pause the screen and try to do the problem by yourself. So I'm just going to assume that you're doing that for the rest of this video. So step 1 is to make a list of the zeros. So where does f of x equal 0? That's going to be at x equals 2 from this factor, and x equals 7 from that factor. Now we make a sign chart. I'll label it as f of x. We have a row for every factor, so we're going to put 4 here, x minus 2 here, and when you write down your x minus 7, include the exponent. So write down x minus 7 squared. All right, and here we're going to put the 0 of 2 and the 0 of 7. Now let's decide whether these factors are positive or negative in each interval. The constant of 4 is, of course, positive in every interval. X minus 2 gave us a 0 of 2. It will be negative to the left and positive to the right. X minus 7 squared is going to be positive in every interval because when you raise something to an even power, it turns positive no matter what. F of x overall will be negative in the first interval because we have only one negative, and it will be positive in the other two intervals because it's all positives. We are interested in the intervals where f of x is positive because we want to know where f of x is greater than or equal to 0. So because we have these two consecutive intervals and the number in the middle is included, right, because we want greater than or equal to 0, so that makes the even the 7 is included in this, then we don't need two separate intervals. Our solution can be one interval that goes from 2 to infinity. In fact, maybe I'll highlight the 2 also, just to emphasize that because of the or equal to, the 2 and the 7 are all included. So we will say bracket 2 to infinity. Number 4, let's start off making our list of zeros. F of x equals 0. Where? Well, that's going to be at x equals 0 from this first monomial factor. And then there's going to be another one at x equals -4 because of that factor right there. time for the sign chart. Label as f of x. We have a row for every factor. So we have negative 7x squared, and we have x plus 4 squared. And we have the zeros of negative 4 and 0. Make sure these are in order from least to greatest. This is a number line. Now let's decide whether these factors are positive or negative in each interval. This first factor is going to be negative in every interval. X squared is always positive, so that's not going to change anything. But then if I take that positive and multiply by negative 7, then that's going to be always negative. So that's always negative. The next row is going to be all positive, because if you square something, that's just always going to be positive. So overall, that tells me that f of x is going to be negative in every interval. We are looking for where f of x is greater than 0. So we're looking for positive intervals, and there are none. So there's going to be no solution here. Notice that we would still have a solution if this had said greater than or equal to 0. Then the solutions would have been x equals negative 4 and x equals 0. Basically, these would be the solutions right here if it had been or equal to. But since we only want the intervals where f of x is greater than, not equal to 0, there are none of those. Number 5, let's start off by making our list of zeros. So f of x equals 0 at x equals 0 from this first little guy in the front, x equals negative 8 from the second factor, x equals positive 3 from the third factor. Always label your sign chart, put that f of x. We have a row for every factor, so this will be x plus 8 squared, and then we will have x minus 3. In order from least to greatest, the zeros are negative 8, and then 0, and then 3. Now, are these factors positive or negative in each interval? X gave us the 0 of 0. It will be negative to the left and positive to the right. It doesn't matter which 0 came from the x plus 8 squared because it's squared. A squared factor is always going to be positive. Any even exponent is going to make the factor positive in every interval. The x minus 3 gave us a 0 of 3. It will be negative to the left and positive to the right. The overall sign of f of x in the first interval is positive because I see an even number of negative signs. Similarly, it will be positive in the second interval, same reason. It will be negative in the third interval because of the one negative sign, and positive in the last interval because of all the positives. We are looking for the values of x that cause the polynomial to be less than or equal to 0. So that's going to include where f of x is negative. Because we want the x values that cause f of x to be less than or equal to 0, then we're going to include these exponents in the solution. And we will show that with brackets. So the solution will be 0 to 3 with brackets. I like to use interval notation, so that's what I've been demonstrating. But if you run into a multiple choice question or something, they might show the answer like this. So just please understand that this inequality means the same thing as this interval notation. Number 6, let us list off our zeros. Where does f of x equal 0? That's going to be at x equals negative 5, at x equals 1, and x equals 9. Time for the sign chart. Let's call it f of x. We have a row for the x plus 5, a row for the x minus 1, and a row for the x minus 9 squared. And then the zeros, in order from least to greatest, are negative 5 and 1 and 9. Are these factors positive or negative in each interval? Well, x plus 5 gave us a 0 of negative 5. It will be negative to the left and positive to the right. X minus 1 gave us a 0 of 1. It will be negative to the left and positive to the right. X minus 9 squared is always positive because it is squared. Positive, 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 positive. The overall sign of f of x is positive in the first interval because we have an even number of negatives. Similarly, it will be negative in the second interval. We only have one negative, and it will be positive in the last two intervals. We are looking for values of x that will cause the polynomial to be less than 0. So that's where f of x is negative. Because it didn't say or equal to 0, we are not going to include the endpoints in the solution. We will show that the endpoints are not included by using parentheses. So you can write the solution like this or like this. Number 7, we're going to start by finding the zeros of the function. So where does f of x equal 0? That's going to be x equals 0 from this first factor in the front, the monomial. And then we have x equals negative 4 from the second factor. And x equals positive 2 from the third factor. Now we make the sign chart. We have a row for the negative x. We have a row for the x plus 4 squared. And we have a row for the x minus 2 squared. And then across the top we put the zeros in order from least to greatest. So negative 4, 0, and then 2. The negative x gave us the 0 of 0, and negative x will be positive to the left of 0 and negative to the right of 0. Whoops. X plus 4 squared will always be positive because when you square something it's always positive, and x minus 2 squared will be positive in every interval for the same reason. Overall sign of f of x will be positive, positive, negative, and positive. Because of the even number of negative signs here, we get a positive. We are looking for the x values that cause this polynomial to be less than or equal to 0. So we are interested in the interval where f of x is negative, that's less than 0, but because of the or equal to, we will include the 0 and the 2. When we write the solution, we will show that 0 and 2 are included with a bracket. And here's how the solution would look as an inequality. Number 8. Let's find those zeros. So we have 1 at x equals 0 from the monomial. We have 1 at x equals negative 7. And we have 1 at x equals positive 4. Time for the sign chart. We have a row for each factor. So we have x to the third, x plus 7, and x minus 4 squared. Don't forget the exponent that does affect the answer. And we have the zeros in order across the top. So negative 7, 0, and 4. Now we need to decide whether each factor is positive or negative in each interval. An odd exponent does not affect the sign. So x to the third power is equal to 0 at 0, and it will be negative to the left and positive to the right. X plus 7 will equal 0 at x equals negative 7. It will be negative to the left and positive to the right. X minus 4 is equal to 0 at x equals 4. However, because the whole factor is being squared, this factor will be positive in every interval. Now, what about the overall sign of f of x? In the first interval, the two negatives mean that f of x will be positive. The single negative in the next interval means f of x will be negative. All positives means f of x will be positive in both of these intervals. Are we interested in where f of x is positive or where f of x is negative? We are looking for where f of x is greater than 0. So the solutions will be in these intervals where f of x is positive. I've left the zeros themselves as open circles. They are not to be included because these are the places where f of x is equal to 0. We are looking for where f of x is greater than 0. So these open circles show that these points are not to be included. When we write the solution set, we will use parentheses at these endpoints, also showing that these values are not included. So the first interval will be from negative infinity to negative 7, parenthesis, and then union 0 to 4, union 4 to infinity. Caution! Do not try to make one big interval from 0 to infinity. This is wrong because it includes a point where x is equal to 0, not greater than 0. So do not do this. That's a common mistake. And here's what the solution would look like written with inequalities. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.